You've learned how to graph quadratic functions when you use both standard form and the vertex form. We're going to do the two of them side by side and look at some of the key features. So let's first identify in standard form the A is 3, the B is 12, and the C is 7. What can we tell from that? We can tell the direction of opening because the A is positive, it opens upward. Easy. We can find the axis of symmetry. We need to use the formula. X equals the opposite of B over 2 times A. So in this case, our B is 12 and our A is 3. So I get the opposite of 12, which is negative 12, divided by 2 times 3, which is 6, which gives me negative 2. Then I need to write the equation. Remember, the equation of the axis of symmetry is the equation of a vertical line, x equals negative 2. And then from there I'll find the vertex. So I'm going to use the x value found here in the axis of symmetry. And then I need to calculate what the y value will be by substituting back in the original function. So I had y equals 3 times my x squared, so my negative 2 squared, plus 12 times my x, plus 7. Following order of operations, I get y equals 3. Negative 2 squared is a positive 4, plus, keep the multiplication for the next step, and then from here I'll just continue simplifying. Y equals 12 minus 24 plus 7, and when I simplify that I get y equals negative 5. So that's the rest of my point name for my vertex. Now I know the equation for the axis of symmetry, I know my vertex, and I can find the y-intercept right from the equation. Remember, it's the c value. So I look at my c was 7. So my y-intercept will be a point on the y-axis of 7, which has the name of 0, 7. Okay. Now, I can actually go from here, graph my axis of symmetry, plot my vertex, plot my y-intercept, and reflect it. So I only need one more point, and then I'll have my 5 points when I'm done. Quick and easy. Let's do the axis of symmetry on our graph first so that you can see what would make sense for an additional point name. So I'm going to draw my axis of symmetry at negative 2. So on the coordinate plane, 2 spaces left of the origin, we use a dashed line because it's not really part of the graph, it's just a helper tool for us to see where we're going to have our reflection. I'm going to plot the vertex at negative 2, negative 5. So I plot that point. I plot my y-intercept at 7, so from the origin up 7, 1, 2, 3, 4, 5, 6, 7. I'm going to reflect that. How many spaces to the axis of symmetry is going to take? 1, 2, so I go 2 the other way. 1, 2, and that's my reflection. So I want to find an x value somewhere in here, somewhere on the same side of the axis of symmetry as the y-axis is. I'm going to pick that point. I'm going to pick the x value of negative 1. That's going to be the one I'm going to calculate in the original equation. So 3 times my x squared plus 12x plus 7. Whoops, that x I'm going to replace with my negative 1. So I put a negative 1 there, a negative 1 here, and I'm going to simplify. So my y is going to be equal to 3 times 1 plus, it's not going to be plus anymore, it's going to be plus a negative 12 because 12 times negative 1 would be negative. Simplifying all the way down, I get y equals 3 minus 12 plus 7. So y is going to be equal to negative 2, when x is negative 1, y is negative 2. I plot that point, negative 1, negative 2, and I reflect it, 1, 1. And then I can connect those points and I'll have a parabola. Let's, before we connect those, look at the vertex form. So I'm going to take the vertex form, identify my a, my h, and my k, because that's what is given in this formula. My a is a positive 3. My h looks like the opposite of that because it's whatever I'm taking away from x. So in this case it's negative 2. And then negative 5 for my k. Which way does this open? It opens upward because the a is a positive value. The axis of symmetry I read right from here. My x is equal to my h value. That is the axis of symmetry. No calculating required. The vertex 2, I don't have to calculate anything. It's the h comma k. So my h is negative 2. My k is negative 5. And look at this. We have the same vertex, the same axis of symmetry, because these two equations, even though they're in different forms, are actually describing the same parabola. Because we don't have a y-intercept when it's in vertex form, we actually need 2 additional points. So I'm going to pick easy numbers. I'm going to pick when x is 0, because I don't have a y-intercept, but I can calculate it. And I'm again going to pick when x is negative 1, because my axis of symmetry was a negative 2, so I know I can go left of the y-axis to find another point. Since I've got 2 points, I'm going to make a table of values. I'm going to put in my x so that my y comes out, following the rule that is my equation. So when I look at the right side of the equation, the y is equal to 3 times parentheses x plus 2 squared minus 5. I'm going to use those 2 input values. I'll do one at a time. 3 times the quantity 0 plus 2 squared minus 5. Order of operations says parentheses first, and then exponents. So I get 3 times 4 minus 5, which is 12 minus 5, which gives me 7. So 0 in, 7 out gives me a point, 0, 7. If I look at where we plotted before, you'll see that 0, 7 is one of our points. It's the y-intercept, but we had to calculate it when it was in vertex form. When I calculate the negative 1 using the vertex form, negative 1 is my input. I take 3 times the quantity negative 1 plus 2, square that, minus 5. 3 times negative 1 plus 2 is 1, squared minus 5, which gives me 3 times 1 minus 5, which is 3 minus 5, which is negative 2. Negative 2 is the output when negative 1 is the input. That's a point name, negative 1, negative 2, and I plot that point. Negative 1, negative 2. So you can see that these were actually 2 different versions of the same parabola, just 2 different forms. Comparing and contrasting standard form and vertex form. You have a card match in Desmos. Have fun with that. Bye.